Hi there, welcome to this build of this iconic 40-inch wingspan Keil Kraft Gypsy. Now this is a fantastic design by Bill Dean from 1949. Now I'm building this, or I started building this from a Ripmax kit, which if you've seen the previous videos you'll know I'm not particularly happy with. And I've had to replace some of the bits with my own materials. The plans were the wrong size. I've had to download the original plans from AutoZone and print them out myself. Now if you want the plans for this from AutoZone, there'll be a link in the description below this video. Now you can see we've got the skeleton of the fuselage finished now, and I've got the wings stowed up there safely as well, which we built in a previous episode. Now in the last video I got the dethermalizer set up, or at least, yeah, so I got the tailplane, tail assembly set up for a dethermalizer. And what I need to do now is install the electronics. What I didn't do in that last video, and the reason I kind of hesitated, is because I did the attachment and everything like that, but I didn't install the electronics, the actual mechanism for it. And that's what I'm going to do in this video. This build is going to be 2-channel. It's going to have 2 micro servos, just really small, I think they're 4.4 gram servos, and I'll put a link in the description below to where you can get these. And I'm going to have 2 servos, one to control the rudder and another to trigger the dethermalizer. And I want to have both servos around the CG point, because I'm assuming that when this was designed that it would actually balance on the CG point and it had no electronics. So any electronics I add I'm going to put on the CG, and hopefully we will retain that balance. Finally I'll be able to fine-tune the balance by a battery. I'm going to use quite a small battery, and I'll have a look at that in a bit, and we can move that just to get that CG right. But as I said, we're going to put the electronics in. So we'll have a very quick closer look and then I will get on. So the first thing I'm going to do is install this micro servo just around the CG to trigger this cord for the dethermalizer. And I just want to mount it somehow so the arm of the servo is just sticking down below the fuselage. And what we can do is we can just loop the cord around that arm, or maybe elastic band, just so there's a little bit of tension, and then we can have that connected to a switch on the transmitter, and we'll just flick it and it will trigger the dethermalizer. So that's the first thing I'm going to do, install that servo. The next thing I need to do is I need to install a servo up around here to allow the rudder to operate. And what I'm going to do is I'm going to have let me just take these elastic bands off so it doesn't keep flicking up. Right, so what I'm going to do is I'm going to have a push-pull cable network. So we're going to have a servo mounted somewhere on the CG. We're going to have 2 cables coming down to a control horn either side of the rudder, and we will just have, like I say, a push-pull system to operate that. Now one of the problems that we've got is that we don't have, well, there's two issues we need to be very mindful of. One, if we look down the centre of the fuselage, we can see the black carbon fibre peg at the end, hopefully. Now we need to keep that line clear, because we need to be able to install the rubber motor from the front end right down to the back. So we can't have any radio gear in the way, or batteries or leads or anything like that. So this servo for the rudder is going to be up in the cabin top section here, so above this line. So I need to think of a cradle, a frame to hold that servo. The push-pull cable, I'm going to be using this, I think it's called Fishing Trace. I got it from a local store. It's recommended by a good friend of mine. And it's 7-stranded, it's just plastic coated fishing, like I said, I think it's called trace. I'm not a fisherman, but I think that's what he said it was called. Now I want to have a line coming from a horn fairly low down there to there, but I haven't got a very good straight line to that, because to do that I'd have to bring the cables out quite high back on the fuselage, about here, and I'd much rather they came out right at the back. So what I'm going to be doing is putting in a little bit of carbon fibre around the back end here, so the cables can come down the fuselage and then be diverted by the carbon fibre which they're just rubbing against and go up to a control horn on the rudder. So I think that'll just be a lot neater, like I say, than having cables that are coming right open out the top of the fuselage. In fact, they would have to come out round about here. That's quite long visible cables, which I don't want. So anyway, I will get on and start to make up some of these cradles and pull this all together. Right, well, I've now got the dethermalizer set up to a servo, and I've just got a single servo mounted in there, and the idea is just something that is easy, light, and simple really. And I'm going to have a hatch on the bottom here, so that will be accessible. I'll be able to get at it, and you can see that the cord from the dethermalizer, tensioned with this elastic band, is just hooked around the servo horn, and we can just see that in operation now using the servo tester. There we go, simple as that. And eventually, after I've covered it, I will have, let me just put this back, I will have a tube on the underside of the fuselage just to limit the movement of this cord. So if you see when it goes off now, the cord is trailing out the back, but what we'll do is we'll just retain that on the underside in a bit of tube. So we've got that done, and that will connect straight into the receiver, which is going to be around in this area, which is where the CG is. So now I'll get the servo mounted for the push-pull mechanism for the rudder. I do need to hinge the rudder, but I haven't cut it out of the kind of the tail or the fin assembly, because I want to get it all set up first, and then I'll cut it out and hinge it up. But I'll get that servo in now and get this put together. Right, well, I've made a servo mount, and I thought I'd just show you before I mocked it up in the fuselage. Essentially what I've got is just two bits of really light softball, so there's very little weight to this, and a couple of pieces, a couple of blocks of spruce. You can see that there, just held together as a cradle. And what I've done is I've done a very small aluminium tray there to hold the servo. I've got some servo screws, and that will just slide backwards and forwards so I can tension the push-pull cables. Because of the dethermalizer coming up and down, if there's any stretch in the cables or even temperature may affect it. So I just thought it'd be nice to have something to be able to adjust the servo position, only by just a few millimeters. It's probably about, in fact, let's have a look, see how far it does go, because I haven't actually checked it. Now, it's about 5 mil, so what's that, quarter of an inch, something like that. And that is going to go up here. And I want to try and get the servo arm, which is going to connect to the push-pull mechanism, kind of centrally on the fuselage here. I don't want it to line up with a cross member or anything. I want to be able to get easy access to it. And I've got these formers that are going to hold it, and you can see I've cut some out there just to make sure that we're clear of that rubber motor. So I'll get this installed now, and we'll have a look, see how it looks. Right, well, I've got that servo mount in the fuselage now, and hopefully you can see that okay. And there is going to be some adjustment to it. I think I obviously need to cut off the tails back here because I don't need those sticking out. But what I'm going to do is I'm going to take out the central piece of this former here, and that will allow the mount just to go forward slightly so that the servo arm is more central within this area here. But that's looking good. I'm really pleased with that. And if I don't know whether we can look down there, we can see we've still got a clear a clear path down to the rubber anchor at the back. You can see these tails, but once these tails are cut off, it'll be even better. So I'm going to get that modified and glued in, and at the same time I'm going to make a horn, or a control horn for the rudder down at this end. And I'm going to be using some 1mm epoxy board, which I was just getting hold of, and it's just epoxy board. It's like a fiberglass board, and it's really strong, and it's great for making these kind of control horns. So I'll get all that done and we'll have a look, see how it's looking. Right, I've really been cracking on with this now, and I've got the servo mounted in there, bolted in, and the bearers for the servo mount all cut to length. We can see that in there. I haven't glued it in yet. I just wanted to make sure everything was right before I put some CA on it, and it didn't move again. So I've got some trace line on that now coming down to the tail, and you can see there's a piece of 2mm carbon rod here which I've put in, and that is just going to provide a little bit of a bearer, a pivot point, I don't know what you'd call it, just so that the tracer can then curve around that and angle up to the control horn on the back of the rudder. What I will do is I'm going to find some really light balsa to put in this back section, I think, and then cut out a slot for the tracer to come out. If I don't do that and I just put a hole in the tissue, it's going to rip and tear, I'm sure. So I don't like putting balsa in the back here, because we want to keep this as light as possible, but just the lightest balsa I've got and it'll be fine, I'm sure. Now at the back here I've got a control horn, which you can see I've just cut out from this epoxy sort of fiberglass board, 1mm, and I've got a couple of, hopefully that's in focus, there's a couple of holes for different distances. Now it's that shape because it's important that I'll just zoom in on this. It's important that the holes, the connection points for the two cables, line up with the centre of the hinge point here, if we're going to get good movement. I know it's not a patterns plane, it's not an acrobatics plane. We just want to put some input to keep it on the airstrip, but we might as well do it properly. So that's going to be like that. I'm going to put some of these small Dubro hinges into there. What I'm going to do now is I'm going to cut out the rudder, sand it up, and put those hinges out, and then hopefully we can get this just mocked up a little bit and see how it works. I obviously can't connect the cables until we've got it all covered and the control horn glued in. I'm not going to glue the control horn in until I do have it covered. I've got a little bit of balsa here. It'll just make it really difficult to cover. I am going to glue that bit of balsa in like that, and we can then just feed this in the side. It's a bit of a tight fit, but we can cover it like that and then just cut a slot, feed it in, and a little bit of epoxy. So the hinging I'm not going to show. I've done a video which shows how I install these Dubro hinges, and that will be in the description below. There'll be a link to that. So I'm going to get all this pulled together now and we'll see how it works. Right, well, I've got this all set up now and I'm really pleased with how it's looking and how it's working, and I'll just show you it working in a second. Just a couple of points I want to make. I'm using a servo to trigger the dethermalizer, as you've seen. Now you might be thinking, well, why don't I use a separate band burner and setup that will be a lot lighter? Well, actually I have got a BMK, I think it's BMK, band burner and radio here, which needs a separate battery, and actually it works out the same weight as putting in a micro servo. And as I've already got the radio set up in there, I can just plug into, this is by far the simpler option. I did cover this in the previous video, but it'd be just so much better because I can just flick a switch on my transmitter, which I'll have anyway because of the rudder. The other thing I'll just quickly say is I've got this servo set in from these down struts so that it doesn't, this piece of balsa doesn't show on the tissue. You'll still see it because I think the tissue is going to be fairly transparent, but at least it won't be really obvious and really in your face. So let me just zoom in on this and I'll show you first the rudder working and then the dethermalizer. Right, well hopefully you can see everything you need to see here. The rudder, we've got the servo, and I've connected the servo up. It's jittering a little bit. I've used 2 servo testers and this one really is rubbish. But I've connected the push-pull with just some really strong black cotton. I haven't used the trace that I will use eventually. It was just easier to tie the cotton and it's strong enough for a demonstration. So we can see the rudder there moving nice and freely, and I've got holes in this former here we saw earlier. I think I've done the sheeting here for the 2 slots for the cables to come out, or the cords to come out. I've got the carbon fibre that still needs to be trimmed and glued in, but that's a 5-minute job, and we can see plenty of movement there on the rudder, and if I want I can always increase that, but I don't really think it's going to need any more than that, if half that really. And we've got the other servo tester connected up to the dethermalizer, so we can just do that and there we go. We have an active dethermalizer now. We can't use the rudder once the dethermalizer is triggered, but I don't really think that is a problem, and we can then just set this again easily enough. I mean, the rudder's not going to be effective once the dethermalizer has triggered. It's just going to stall and float back down. Now there we go, and we can well, let's just rudder again, and we can just trigger. So there we go. Well, I'm really pleased with the solution that we've come up with in getting this rudder working and the dethermalizer, and I think the solution is quite a lightweight solution, keeping it really down to the minimum weight that we can. The 2 things that I haven't done is put in a location for the receiver and the battery, and I think that will be fairly easy. We've got the hatch that's going to go here. We can just mount it on the other side here, which is on the CG, the receiver anyway. The battery I can move backwards or forwards and just make provision to mount that on a bit of Velcro. But before I decide on those locations, there's a little bit more work I need to do. I need to think about getting the tail assembly covered, and so the tailplane and the fin and rudder. I need to get the wings covered, and I certainly need to get the rubber motor made up and in place. Once we've done that, we can get an idea of where the CG is naturally falling. I know it will change a little bit because of the fuselage covering, but we can get an idea and we work out hopefully where that receiver and battery can go. But as I said earlier, by trying to keep the weight that I'm putting in at the moment on the CG point, hopefully this is going to be pretty well balanced once it's finished. But anyway, we will see. So I'm going to draw this video to a close now, and I hope you've enjoyed watching it and found it interesting and useful. And please come back and see how we get on in pulling together this iconic 40-inch wingspan Keil Kraft Gypsy.